to present a topic called corrosion of metals and its prevention. The topic will be discussed under three headings. Number one, what is meant by corrosion, where the definition and the examples of corrosion will be explained. The second one is, why do metals undergo corrosion? What is the cause for the cause or the reason for corrosion of metals? And the third one is how it happens. That is under the heading, corrosion involves two types, what is called classification of corrosion. And then we are having the last session, what is called the prevention. What are all the preventive methods we can adopt to eliminate corrosion. So that's the topic what we are going to see now. So let us start the heading with the definition of corrosion. Here, corrosion is a process where metal undergoes compound formation by reaction with the surrounding and by reaction with the surrounding environment. So it is the reaction of the metallic surface with the surrounding environment. It is an oxidation process. Corrosion is an oxidation process. It is a slow process. Though it is a slow process, in due course it will lead to large amount of loss, what is resulting in the formation of metal damage or the metallic structure even getting destroyed. So the definition of corrosion is, as such, corrosion is defined as the destruction or the deterioration of a metal by its chemical reaction with the surrounding environment. Here the examples what I can give here is, one is rust, what is iron undergoing oxidation resulting in the formation of iron oxide. What is rust? Chemically it is Fe2O3 H2O compound. And the other example is copper, what is subjected to green scale formation as a result of corrosion reaction. So next is how we can, what is the reason? Here we are studying it under the heading called, why do metals corrode? Metals are occurring in nature, that is in the earth's crust, in minerals, but in the combined form. They are not available in the pure form because metals are very reactive. Only native metals are not reactive, but other metals, apart from our native metals like gold, silver, other metals, most of the metals, they occur in the form of combined state because of their tendency to react with the surrounding environment very fast. So when metals are available in the Earth's crust, they are occurring in the form of oxides, carbonates, sulfates, or even chlorides. Say for example, if you take an ore of iron, it will be occurring in the form of hematite, which is an oxide of iron. And if you see the magnesium, how the metal is present, it is in the form of magnesium carbonate, what is nothing but magnesite. And if you come to aluminium, it is in the form of alumina or bauxite, what we call it as chemically, and this is nothing but Al2O3. And we are having other sulfide ores also, lead sulfide. So all these are examples where a metal is present in the form of a combined state, what is called as ore, what has to be extracted from the mines. So here, by doing metallurgical processes, we are going to extract the metal from the earth's crust. So what is the damage actually caused by corrosion? It is disfiguration or loss of appearance. The metal loses its appearance, which will lead to the material loss, which will again lead to maintenance cost. And by extractive metallurgy, we are manufacturing metal in the pure form from the earth's crust, but it has to be done again. So that is the repeated process what we are suffering here. And loss in reliability and safety. People working in the industries, they are suffering due to this type of material failure, which will lead to human life, loss of human life. And the last one is, it will lead to plant shutdown, indirect loss of product, that is economy, what is called the product shutdown will lead to product loss, and again the contamination of products which are affected by the corrosion products what are formed along with the main contents what we are preparing, main material what was prepared in the industries. So this is how we are going to, that is how it happens. Why do metals corrode? What is the tendency of metals to undergo corrosion? As I already told you, it is ore, which is the available form of metal in the earth's crust. It will occur only in the combined form. So it may be in any form, oxide or a sulfide or a carbonate, whatever it may be, it will be in the combined form only. But in the combined form, it is not useful. Only in the pure form, when it is in the pure form, or in form of any alloy, when it is mixed with some other metal, metal, it can be used for different applications, say for any metallic objects like equipments, instruments, or like for the construction of buildings or bridges or any structure in what is like water boiler or a steam boiler or any instrument or gas pipe what we are using in industries, all are manufactured only by using a pure metal or its alloy form. So we have to get metal in the pure form. For that only we are doing metallurgical process. So after extraction we are getting the pure metal, and this pure metal is when it is used in the different structural objects, we are getting them coming in contact with the surrounding environment. So metallic objects in the form of instruments or equipments or any building or any gas pipeline in the industries, it may have a chance of, it's not it may have, it definitely comes in contact with the surrounding environment. The surrounding environment, what we mean here is the immediate contact, what is the metal is having with the immediate surrounding atmosphere, what is the environment which comes in contact with it. So by reacting with the surrounding environment, the metal and pure metal, which is used in the form of different structural objects, it comes into chemical reaction whereby we are getting some compound formation of the metal, what is called as corrosion product. So pure metal, it is extracted by metallurgical processes from ore, from where it is again going on reaction with the environment. During its usage, it is converted into corrosion product. So corrosion is the reverse of metallurgy. We can call it as reverse of metallurgy, or otherwise it is called as weeping of metals. When it is in the pure form, metal is not thermodynamically stable. What is the stable form? Only the combined form of ore, what is available in the earth's crust, or the corrosion product, what is formed during the usage process. By that is the metal, when it is used in any form, it has immediate reaction with the surrounding environment because of its reactivity, so that it can be converted into a more stable, what is called the thermodynamically stable form, what is the resulting product, what we are calling it as corrosion product. So only in the corrosion product form or in the ore form, the metal is stable, whereas when it is in the pure form, when it is used in the pure metal, it is not thermodynamically stable. So it is thermodynamically unstable. So next we are going to see about what are all the types we are having here for, what are the classification we can have for corrosion. That is, corrosion may be classified in different ways. The two important ways are based on the environment, what it is having. So one is with the aqueous environment or with the dry environment, it may undergo reaction. That is, during summer season, we can have a dry environment, or in the case of winter season or in case of any industrial applications, the metal may come in contact with any acidic or alkaline or neutral medium, which is called a wet environment. So that is one type of classification. The other type is based on the temperature, what is available in the surrounding environment. That is the room temperature corrosion or a high temperature corrosion. Though we are having two types of corrosion here, one what we are going to see in detail is about the first type, what is called dry and wet types of corrosion. When we talk about dry corrosion, it is nothing but the direct contact, direct chemical reaction of the metal with the environment. There is no wet condition. It is direct oxidation reaction, where it can occur in three ways. The first one is oxidation corrosion, the second one is corrosion by other gases, and the third one is liquid metal corrosion. The first type, where the metal comes in contact with oxygen available in the atmosphere, whereby it is forming some different layers, what are nothing but the metal converted into oxide form. So on the metal surface, you have a formation of a metallic oxide, what will act as coating for the metal surface. But this coating is not always it is advantageous. It may be harmful also. The first type, where we have stable protective layers, it is occurring with the case of aluminum, where alumina Al, it is reacting with oxygen Al plus O2 giving Al2O3, which is nothing but a combined form of aluminium. But this Al2O3 is a stable protective layer. It will be there for a period of time, so that it will prevent the metal undergoing further corrosion. So for the first type, though it is a corrosion product formed on the metallic surface, it still protects the metal being further undergoing corrosion. The second one is unstable non-protective layers, where the layer, what is the oxide layer, formed by the metal by its oxidation process, it's not protective. For example, in the case of gold and silver, you have an oxide, but that is not a stable film. That's why it is getting dissolved, and your metal is subjected to further process of corrosion. So the corrosion is not stopped there, it is undergoing as and when the metallic layer containing the oxide film dissolves, you have the corrosion process stimulated, that is its further proceed. And the third type we are having, that is under oxidation corrosion, is another type what is existing in the case of iron, what is called a porous protective layer, porous non-protective layer. Porous in the sense, even though you have a layer formed on the metal surface, the oxygen what is available in the atmosphere can penetrate through the layer what is formed on the metal surface, thereby continuous process of corrosion is going on. So all these three types, they come under the first type, what the first category, what is called oxidation corrosion, where it is metal undergoing direct oxidation with the available oxygen in the atmosphere, whereby oxide layer is formed with it may be either a stable one or a non-stable one or a porous one, whatever it may be, it is a layer what is going to be formed on the surface. It's not the original structure of the metal retained, and it's not so dangerous the first time. And next, we are having corrosion by other gases. It's not only oxygen we are having in the surrounding atmosphere, we are having other gases like hydrogen, chlorine, hydrogen sulfide, sulfur dioxide and carbon dioxide. Here also these gases, when they are available in large amount in the atmosphere where the metal is used, you have these gases undergoing chemical reaction with the metal what has been used for various purposes. So in the case of chlorine, if you see tin, when it comes in contact with a gas like chlorine, we are getting a volatile layer formed, that is stannous SnCl4 it is called. So this is another gas, that is another type of dry corrosion, where you don't have any aqueous medium, just the metal coming in contact with the atmosphere, and the atmospheric gases have the chance of undergoing reaction with the metal surface. And the last type is liquid metal corrosion. In the case of industries, we have pipelines where metals in the form of molten states, they are transported through pipelines, where if the metal in the molten form it is taken, it comes in contact with the immediate metal what has been used for preparing that pipelines. So the metal starts dissolving that immediate pipeline metal what has been in contact with the liquid metal. For example, mercury, it forms amalgam with the metallic pipelines what are used for transporting any liquid. So this is the third type. So far we have been discussing about that. The first type what is called dry corrosion, and here we are going to see about what is actually wet or electrochemical area of corrosion. As the name indicates, it is wet. Definitely you have any aqueous medium to facilitate the formation of corrosion process, what is otherwise called as electrochemical area of corrosion. This type of corrosion occurs when a metal comes in contact with a conducting liquid or any two dissimilar metals are immersed in a solution. Here, one part of the metal will be having more oxidation, will be having more exposure to oxygen, whereas the dissolved part, it will not be having immediate contact with oxygen. So what happens here, there is discrimination in the oxygen exposure to the metal surface, and thereby you have the one part of the metal acting like an anode and the other part acting like a cathode, and the immediate solution what is in contact with the metallic surface, it acts like an electrolyte, facilitating the process of corrosion. So corrosion is an electrochemical reaction where you have a cathode and an anode and an electrolyte, and thereby there is some reaction actually what enhances the metal to react with the environment. So here we have the chemical reaction what is actually going on. Electrochemical theory of corrosion can be explained with this diagram, where you have the metal having some part what is subjected to less exposure of oxygen, what is having the anodic area as well as the cathodic side. You have small dents on the metal surface which have less oxygenated part, whereas the smooth surface, what is the plain surface of the metal, it will be acting like a cathodic site. So there is difference in oxygen exposure of the same metal in different parts. So the less oxygenated part will act like an anode, whereas the more oxygenated part, that is the surface where you have more exposure to oxygen, will act like a cathode. So the same metal is behaving like a anode at one part, and it's behaving like a cathode at another part, and you have the transfer occurring in between these two sites, where you have the actual corrosion product formed, what is nothing but rust. The chemical formula for it is Fe2O3 H2O, which is nothing but the original form of oxygen, original form of iron, which is a very stable combined form of iron. It is iron getting oxidized. The first step, where it is behaving like an anode, where you are getting the electron removal taking place, and that electron removed by this site, what is like acting like an anode, that will be taken up by the surface of the metal, what is behaving on the other part, what we are calling it as a cathode. So at that site we have oxygen, and then the H plus reacting and taking up this electron to form a H2O, what is a liquid, what is actually present near the surface where the metal coming in contact with this aqueous medium. So electrochemical theory, definitely it suggests that there should be an aqueous medium to support this transfer of electron, so that one part will act as an anode and the part will act like a cathode, and you have the immediate corrosion product formed in between these two sites. Next we will see how electrochemical theory of corrosion can occur in two ways. The first type, it is evolution of hydrogen, which is very common in the case of industries where metals are subjected to pickling process. Here definitely we are going to use any acid, mineral acids like HCl or sulfuric acid for pickling process, which is nothing but descaling of the metal surface after repeated exposure to various industrial processes. Now what is happening, the first step is the usual step, which is nothing but iron or any metal getting oxidized, what is resulting in the formation of removal of electrons. The second step